This is Video Solutions to Practice Test B. This is number one. Number one is negative 2a to the negative fifth power, in parentheses, times 4a to the negative second power. Now, I want you to notice that your negative 2 and your positive 4 are not being raised to a power. In order for them to be raised to a power, we would have to have an exponent right here or right here. Okay? And we don't. So all we need to do is multiply these two together. So we have negative 2 times 4, and that is negative 8. Negative 8 is different than 8 to a negative power. Okay? That is different. This is just good old negative 8. Okay? Now we're going to look at a to the negative fifth and a to the negative 2. Think about that the same way you would think about x squared times x to the third. They have the same base. They're being multiplied together. So what do I do with x squared times x to the third? What do I do with those exponents? Add them. So that would be x to the fifth. We are going to do the same exact thing with the negative 5 and the negative 2. So I have a to the negative 5 plus negative 2. And negative 5 plus negative 2 is negative 7. Now, on your quiz, I had a decent number of students stop right here. They didn't go any further than negative 8a to the negative 7th. Okay? This is not fully simplified. You're only fully simplified when all of your exponents are positive. I have got to move the a to the denominator. And that is different than moving the 8 to the denominator. The 8 is just negative. In order to move the 8 to the denominator, it would have to be 8 to the negative 1 power. That's when you would move the 8 to the denominator. But that's not what we have. What we have is just negative 8. So the only thing I'm moving to the denominator is the a. So my negative 8 stays in the numerator. My a to the negative 7th becomes a to the 7th. And that is my final answer.
Okay, so only negative powers are in the denominator.
Correct. Only your negative powers get moved. Now, Tyra, if you had a negative power, so let's say I had 1 over x to the negative 2. That time you've got a negative exponent in the denominator, so you're going to move it up. So it is, you do the inverse. So if it's in the denominator, you move it to the numerator. If it's in the numerator, you move it to the denominator. Great question. Okay, number 2. And I didn't have time to write these all out, so bear with me. So I have 4x to the third, y to the negative fifth, over 7xy to the negative third, z to the negative fourth, all of this to the negative 2. Okay, now, what you have here that's different than what we had on the one before is we have a negative 2 outside of everything, outside the parentheses. So this negative 2, it belongs to everything inside the parentheses, including numbers. Okay? So the first thing I'm going to do is I'm going to give that negative 2 to everything. So that means 4 to the negative 2 power, x to the third times the negative 2 power, because a power to a power, we multiply, y to the negative fifth times the negative 2 power, then I have 7 to the negative 2 power, x to the negative 2 power, y to the negative 3 times negative 2 power, and z to the negative 4 times negative 2 power. Okay? Now, the only thing that I'm going to do in my next step is I'm going to multiply all those exponents that I need to multiply together. I'm not going to move from top to bottom yet. I'm just going to multiply. So I've got 4 to the negative 2. Then I have x to the negative 6th. Y to the positive 10. Then I have 7 to the negative 2. X to the negative 2. Y to the positive 6. And Z to the positive 8. Okay? Now, I can do some of these more than one way. So I'm going to try to hit all of them so that you can be aware. The first thing that I'm going to do is I'm going to deal with my 4 to the negative 2 and my 7 to the negative 2. That's what I'm going to deal with first. My 4 to the negative 2 goes to the denominator and becomes 4 squared. So once you move it to the denominator, you get rid of that negative. My 7 to the negative 2, because it's in the denominator, it goes to the numerator. Okay, now, I want you to look at x to the negative 6 and x to the negative 2. Some students would like to go ahead and move those. That's just what they want to do. They want to say x squared in the numerator and x to the 6th in the denominator. Okay? And that's completely okay. But then in the next step, you're going to have to cancel some more. Because you're not done with those x's. But some students just want to get rid of those negative numbers. And that's okay. Now, another way to do that is you might want to do x to the negative 6 minus negative 2. I am subtracting the two different exponents. Why am I subtracting? Because I'm dividing. So that becomes plus a positive. So that becomes x to the negative 4th in the numerator. That is an okay way to do it. Eventually, what are we going to have to do with that x to the negative 4th? Move it to the denominator. So you can do it either way. Either way is completely fine. Okay? Now, let's look at my y's. Y to the 10th and y to the 6th. Okay? That is y to the 10 minus 6. What is 10 minus 6? 4. So my y's are going to stay in my numerator. Okay? Then I have z to the 8. Do I have any z's that I need to cancel with or divide or anything? No. So my z to the 8 is going to stay there. Now, I'm not done yet because I still need to deal with that x to the negative 4th. Where does that x to the negative 4th go? The bottom. Good. Okay, now, if you choose to leave 7 squared as 7 squared, I'm going to give you credit for that. I'll give you full credit. Okay? Some students like to go ahead and turn 7 squared into 49. So I have 49 in the numerator, and then I have y to the 4th in the numerator. Then I have 16 in the denominator. My x to the negative 4th moves to the denominator as x to the 4th. Then I have z to the 8th. Okay, and it's always a good idea to look one more time and make sure you've canceled everything that can be canceled. Okay? Is it okay? Oh, yes, ma'am.
Why is 8 in the
Z to the 8. Okay, so I want you to go back and I want you to look right here. Okay, do you see the Z to the negative 4 times negative 2?
Oh, okay.
When I multiplied those two together, I ended up with a positive exponent, so it stays in the denominator. Good question. Okay, can I move on to number 3? Okay, number 3 is the square root of 60. Square root of 60. Okay, so what we want to do is we want to break the square root of 60 into a perfect square factor. Now, some people would say, oh, that's 6 times 10. 60 is 6 times 10. But is 6 or 10 perfect? No. So not helpful. Okay, some people might say, oh, that's 12 times 5. 60 is 12 times 5. But is 12 or 5 perfect? No, doesn't work. So what is perfect is 4 times 15. 4 times 15 is 60. 4 is perfect. The square root of 4 is 2. And so I get 2 on the square root of 15. Now, if you don't know that 4 times 15 is 60, this is what you can do. You can break it down into primes. I can say, okay, 6 times 10. Then I've got 2 times 3 and 2 times 5. So inside my square root, I'm going to have 2 times 2 times 3 times 5. Now, I have a set of 2's inside the parentheses. When I have 2 2's inside, how many do I write on the outside? Just 1. Then what do I have left on the inside? Good. Okay, so prime factorization is always an option. It's always an option. Okay? Can I move to the next one? Okay. Now, this one, I teach a trig class at night, and rationalizing the denominator even makes my trig students crazy. Okay, so I've got the square root of 27 over the square root of 5. You are not allowed to have a square root in the denominator. Okay, so that's not allowed because it's a square root. So I have to get rid of that. How do I get rid of it? I do. I multiply. So I am going to multiply by the square root of 5 over the square root of 5. When I multiply by the square root of 5 over the square root of 5, what am I multiplying by? 1. I'm multiplying by 1. Okay? Now, some students will multiply 27 times 5. Okay? 5 times 7 is 35. 5 times 2 is 10. Plus 3 is 135. Okay? Some students may do that. Okay? 9 will go into 135. 9 goes into 13 one time. 9 goes into 45 5 times. So 9 times 15 is 135. That is more cumbersome. Let me show you how I would do this problem. I would immediately identify that the square root of 27 has what in it that's perfect? 9. So this is what I would do. I would say 9 times 3. Okay, what's the square root of 9? 3. So I'm going to bring the 3 on the outside. Now I'm going to deal with this square root of 5 in the denominator. So now I've got the square root of 5 over the square root of 5. What's So 3 stays on the outside. Then I have the square root of 3 times the square root of 5. What's the square root of 3 times the square root of 5? Square root of 15. And I have gotten rid of square root of 5 times the square root of 5 is the square root of 25. And what's the square root of 25? 5. So you actually have 2 things that you're doing here. Okay? In this part, and a lot of you got one of the parts right on the quiz, but you're actually doing 2 different things. You are simplifying the square root of 25. Okay? You are simplifying. So the square root of 27 becomes the square root of 9 times 3, which is then 3 on the square root of 3. So that's the first thing that you're doing. The second thing you're doing is called rationalizing the denominator. That is when we get rid of the square root in the bottom. So we are multiplying by the square root of 5 over the square root of 5. So you are doing 2 things there. Okay? And if you simplify that numerator first, you're going to deal with smaller numbers. Let me write that down. Simplify numerator first. Because you deal with smaller numbers. Okay? Can I go on to the next page? Okay. Okay. So this one, number 5, is n plus 4 equals the square root of n plus 4. Now, the one on the quiz confused students because the square root was not by itself. I don't remember exactly what the one on the quiz was like, but it was something similar to the square root of x plus 13 plus 7. It was something like that. And a lot of students messed up because they didn't bring that 7 over first. The very first thing that you needed to do on the quiz was isolate my square root. So I needed to have something that looked like this on my quiz. Then I could square both sides. Fortunately for us, our square root is already isolated. The square root is already isolated. So what we're going to do now is we're going to square both sides. If it's not isolated first, then you would need to isolate it. But this one is. So I'm going to have n plus 4 squared. N plus 4 squared means n plus 4 times n plus 4. Okay? So I'm going to write this off to the side. N plus 4 squared, you must FOIL. You must FOIL. Okay? It's not n squared plus 16. Students want to do that all the time, and it's not n squared plus 16. Okay, so now I've got n times n is n squared. N times 4 is 4n. 4 times n is also 4n, and 4 times 4 is 16. Okay? So I have n squared plus 8n plus 16 equals n plus 4. Now I am going to subtract n from both sides. What else do I have to subtract for both sides? Good. So I'm going to subtract 4 from both sides. And I'm left with n squared minus 7n plus 12. Fortunately for us, that factors nicely. What does it factor to? What two numbers equal 12 when you multiply them together and negative 7 when you add them together? Three and?
Wouldn't 7 be positive?
Oh, yeah. Thank you. It is positive 7. Okay, well then I messed you guys up. So what two numbers multiply together that give me positive 12 and added together give me positive 7? 3 and 4. Thank you. Okay. So now I set each one equal to 0. So n is negative 3 or n is negative 4. Now, don't assume that both of them work. You have got to check both of them. You have to check both of them. One of them may not work, both of them may not work, or both of them may work. You've got to check it. So I'm going to check negative 3 first. So I have negative 3 plus 4 equals the square root of negative 3 plus 4. Negative 3 plus 4 is 1, and then we've got the square root of 1. What's the square root of 1? 1. So are we good? Yes, we are good. Now I'm going to check negative 4. So I've got negative 4 plus 4 equals the square root of negative 4 plus 4. Can I take the square root of 0? Am I allowed to take the square root of 0? Yes, the square root of 0 is just 0. So they both work, and it's not often that they both work. Just FYI, it is not often that they both work. Okay? Can I go to the next one? Okay. Oops. This may be like one you had on your quiz, so sorry about that. Okay? 4x squared equals 1 plus 7x. It was interesting to me on the quiz because a lot of people subtracted 4x squared from both sides. It was interesting to me because I always like to keep my A positive. But you know, it worked out okay. But it was something I was not expecting to see. So I am going to subtract 1 from both sides, and then I'm going to subtract 7x from both sides. Okay? So I end up with 4x squared minus 7x minus 1 equals 0. This is cannot be factored, and it is also not really a good candidate for completing the square. You can complete the square. It's just kind of ugly. So I would do the quadratic formula. So I've got negative b plus or minus the square root of b squared minus 4ac over 2a. Okay? My a value is 4. My b value is negative 7, and my c value is negative 1. So I have negative 7 plus or minus the square root of b squared minus 4 times a times c. And that is all over 2a. Okay? Negative 7 is positive 7 plus or minus the square root. Negative 7 squared. That parenthesis is super important. Negative 7 squared is 49. Negative 4 times negative 1. That is going to be positive 16. Negative 4 times 4 is negative 16. Times another negative makes it positive. It's all over 8. So, my final answer here is 7 plus or minus the square root of 65 over 8. I think that is exactly what one of the answers to your quiz questions were. Okay? Now, you can do, like number 6 and 7, you can do the method of your choice. Okay? If you don't want to use a quadratic formula, you can complete the square. If you don't want to complete the square, you can use the quadratic formula. Okay? Okay. Is it okay if I go to number 7? Okay, number 7 is x squared minus 4x equals 13. Okay. I'm going to pull that 13 over to see if I can factor it. Okay, so I'm going to have x squared minus 4x minus 13 equals 0. So I'm looking for two numbers multiplied together that give me negative 13 and added together give me negative 4. Okay, and there are no such numbers. 13 is prime, so that's usually a good indication that you're going to have to do something different. This is a good candidate for complete the square. The reason is my A value is 1 and my B value is even. Okay, that is often when I will complete the square. So that's what we're going to do. So I've got x squared minus 4x. I am moving that negative 13 back to the other side. Okay. What is half of negative 4? Negative 2. So 1/2 of negative 4 is negative 2. What's negative 2 squared? 4. So I am going to add 4 to both sides. I'm adding 4 to both sides. Now, some students factored this incorrectly on the quiz. X squared minus 4x plus 4 factors to x minus 2 squared. There was a decent number of students that put x plus 2 squared. Okay? So be careful. Be sure you know what that factors to. It's a perfect square trinomial, so just be careful with your signs. Now I'm going to take the square root of both sides. When I take the square root of the right-hand side, I have to put plus or minus. Plus or minus. So then I am left with x minus 2 equals plus or minus the square root of 17. And my last step here is to bring the 2 over. So my final answer is x equals 2 plus or minus the square root of 17. And could you do that by using the quadratic formula? If you wanted to. Yes, you could. Yeah, you likely would have to simplify at the end, but you absolutely would get the same answer. Okay? Can I go to number 8? Okay. Number 8, this one's a little bit kinder than the one on your quiz. That one on your quiz was a little nasty. Okay. So the first thing that we're going to do here is we're going to find our LCD. We're going to find our LCD. I have to include x, and then I have to include x minus 1. Because x and x minus 1 are two different denominators. This x is not the same thing because x minus 1 is a unit And you have to treat it as a unit. It stays together. So now I'm going to multiply everything times my LCD, which is x times x minus 1. Okay? So I have 3 over x times x minus 1 plus 7 over x minus 1 times x minus 1 equals 1 times x minus 1. Okay. My x's cancel. I'm left with 3x minus 1. My x minus 1 cancels. I'm left with 7x. Here I got 1 times x minus 1. So I'm left with x times x minus 1. That is not nearly as intense as that super nasty one you had on your quiz. Okay. Now I'm going to distribute. 3 times x is 3x. 3 times negative 1. Then I've got plus 7x. X times x squared. I'm sorry, x times x is x squared. X times negative 1 is negative x. Okay? The next thing that I'm going to do is I am going to combine like terms on the left-hand side. Do you see how I've got a 3x and a 7x? That's going to be 10x. And then I'm left with a minus 3. Okay, and that equals x squared minus x. Because that x squared is positive on the right-hand side, I'm going to move things to the right. So I'm going to subtract 10x from both sides, and I'm going to add 3 to both sides. So I've got minus 10x and plus 3. Okay. What's my A value? Good. My B value? Good. And my C value? Good. Positive 3. Did you guys say positive 3? I just want to make sure. Yeah, it's positive 3. Okay, here we go. So, I've got negative 11 plus or minus the square root of b squared. So that's negative 11 squared. And then minus 4. A is 1. What's C? 3. I think it's positive 3. Yeah, it's positive 3. And that is all over 2 times 1. Okay? Negative 11 becomes positive 11. Plus or minus the square root. Negative 11 squared is 121. Okay? Negative 11 times negative 11 is 121. Negative 4 times 1 is negative 4. Negative 4 times 3 is negative 12. So I'm going to subtract 12 right there. Okay? Then I've got 11 plus or minus the square root of 109. 121 minus 12 is 109. And that's all over 2. 109 cannot be simplified further. Okay? Okay. Now, we're moving into lines. Okay? And for those of you that were in my 1 o'clock class on Monday, I hope you watched those videos I sent out. Because of our shelter in place, we had to do it that way. So, I am going to do a little bit different background. Just so we can see this a little bit clearly. This says, graph the line, graph the equation using x and y intercepts. So this is telling us that we are supposed to use x and y intercepts. So I have 2y plus 10x equals negative 10. So it says graph using x and y intercepts. So to find the x-intercept, I have to plug 0 in for what? Y. Excellent. So I'm going to plug 0 in for y. So I have 2 times 0 plus 10x equals negative 10. Feel free to head out if you need to. Don't worry about me.
Pieces of paper to sign up for the exam dates. I'm sorry.
That's okay. Okay. So then 2 times 0 is 0 plus 10x equals negative 10. Okay? 0 is just 0, so I don't even have to write that down. Okay? So now I'm going to divide both sides by 10. My x value is what? What's my x value? Negative 1. What's my y value for this point? What did I plug in for y? 0. So this ordered pair is negative 1, 0. Negative 1, 0. Okay? Now, for my y-intercept, I am going to plug 0 in for x. I do the opposite. So I have 2y plus 10 times 0 equals negative 10. So 10 times 0 cancels out. And I'm left with 2y equals negative 10. Divide both sides by 2, and I have y equals negative 5. My y value is negative 5. What is my x value for my y-intercept? What did I plug in for x? 0. What is a huge mistake that students make, and it is wrong? What is... I'm sorry? Okay, the wrong order. Some students will take my x value here, negative 1, and they'll take my y value here. No, these are two totally separate points. Okay? They are two totally separate points. Okay, now let's see if I can make a somewhat pretty graph here. Okay, I have drawn worse lines in my life. Okay, so we've got my y-intercept. Okay, good. We can do that. Okay. So now I'm going to plot both points. I've got negative 1, 0. So right here, that is my x-intercept. My y-intercept is 0, negative 5. So my line looks something like that. Okay? That is graphing using intercepts. Graphing using intercepts. Okay? Can I go to the next one? Am I good? Okay. The next one says graph using the slope and y-intercept. Hint, solve for y. So I have 5x minus y equals 3. I have to solve for y. I want to get it in y equals mx plus b format. That's what I want, y equals mx plus b format. So the first thing I'm going to do is I'm going to subtract 5x from both sides. Now, you have to be careful because what's with that y that people like to draw? What's in front of that y? A negative. Okay, so that's negative y equals negative 5x plus 3. You can think of that negative y as negative 1y. That may help you to actually physically write a 1 right there. Okay? Then I'm going to divide by negative 1. And I'm dividing everything by negative 1. So then I'm left with positive 5x, because a negative over a negative is a positive, minus 3, because positive 3 over negative 1 is a negative. Okay? Now, I am graphing using the slope-intercept form of a line. Okay? My slope is what? In y equals mx plus b, what's my slope? What represents slope in my formula over on the right-hand side? The m or the b? M. Okay, so my m is my slope. It's always with the x value. So in this line right here, what is my slope? Excellent. So my slope is going to be 5 over 1, because all numbers that don't have a denominator are written over 1. What's my negative 3? What's that? Say that again. It's not my x-intercept, but my y-intercept. So you're very, very close. This is my y-intercept. That is where I start. I always start at my y-intercept. So I'm going to put start here. Okay? So I'm going to start at y equals negative 3. That's right here. Y equals negative 3 is right there. Now my slope, this means I go up 5 and I go to the right 1. Because they are positive, I'm going to have a positive slope. So I'm going to go 1, 2, 3, 4, 5, and I'm going to go over 1. So this is what my line looks like. I did not mean to do it with that marker, but that works. Okay? Okay. May I go to the next screen? Okay. So what I have right here for number 11, I have y equals 2. And for number 12, I have x equals 2. So we've got to decide which one of these is horizontal and which one of these is vertical. Okay, so one of these is going to go to the left and the right. The other one is going to go up and down. Okay, now, if I were to create a table of values, for number 11, when I have y equals 2, what will all of my y values be? 2, every single one of them. So if you get confused, make a table of values. What can my x be? What can my x be? Can it be negative 2? Can it be 0? Can it be positive 5? Okay. My y in this situation, y must be 2. And that's because of that right there. Okay? It says that y equals 2. Every single time, all day long, y must be 2. X can be anything. Okay? X can be anything. It can be -2, it can be -10, it can be -30, it can be +30, it can be 1/2, it can be -1/2, it can be -1/5. Okay? But every single Y has to be 2. Okay? So in this situation, we have a horizontal line. And just for fun, my slope of a horizontal line is 0. Because this just means I'm staying the same. Now, this X equals 2, in this situation, what is every single X value? Now, this is number 12. What is every X value in number 12? 2. What can Y be? Anything. Okay? So in this situation, X must be 2. Y can be anything. So, what kind of line is X equals 2? Yes. Okay. So, this is a vertical line. Anybody know what the slope is for a vertical line? What's the slope for a vertical line? It's not 0. It's undefined because you get a 0 in the denominator. Okay? For my horizontal line, I would get a 0 in my numerator, and that's okay. It's not okay to have a 0 in the denominator. Okay? We have 2 more super quick problems, and then you guys will be out of here. Okay, whoops, I guess I put number 12 on here twice. Sorry. We are finding the slope of the line that has 2 -6 and -19, +19. Okay? Slope is change in Y over change in X. Okay? Change in Y over change in X. That means I'm subtracting my Y's, then I'm subtracting my X's. Another way to write it is Y sub 2 minus Y sub 1 over X sub 2 minus X sub 1. So I'm going to start with this point right here, and I am subtracting. So I have 19 minus -6. So 19 minus -6. Then I'm going to do -19 minus 2. Okay? 19 minus -6 becomes plus a positive, and that's 25. What is -19 minus 2? Excellent. -21. So you can write this as 25 over -21. You can write it as -25 over 21, or you can write it as -25 over 21. All of those are completely fine. Okay? You cannot write it as -25 over -21, because what have you turned it into? What's a negative over a negative? Positive. So I've just turned it into a positive. Most students keep it at 25 over -21 because they're scared they're going to mess up if they don't. Okay? So as long as you know not to overcompensate for that slope, you're in good shape. Last one. Find the slope of the line that contains the points 3, -5, and 3, -6. Okay? So I have change in y over change in x. I'm subtracting -6 minus 5. So -6 minus -5. Then I'm going to do 3 minus 3. Okay? -6 minus -5 becomes -1. What is 3 minus 3? 0. Is this slope undefined or is this slope 0? Undefined. Excellent. Good. It's undefined. Why? Good, because I've got a number in the bottom. I've got a 0 in the bottom. That right there is what makes it undefined. Okay? If I had gotten 0 over -1, that simplifies to 0. So this is okay. This is not okay. That's what makes it undefined right there. Okay? This would be a horizontal line. This is a vertical line. Okay?